Okay, so we're going to have a review on chapter 21, 22, 23, 24 really quick and prepare you for the next quiz and the next tests. So we're actually done with all of the chapters that I wanted to teach for this semester, and from this week we're just going to practice on JMP and create examples that are related to your quizzes, exams, and project, and hopefully prepare you for the next exams coming up. I want to remind you that all of those JMP instructions I give you here, they were already given to you in the previous videos, but they were more in detail and including the instructions on the previous videos, but here it's going to be a really quick review. And in addition to that, maybe when I'm explaining it you feel you know it, but for exams and for quizzes you will be under stress, you will be under pressure. So I want to make sure that you practice all of these steps several times. And the main reason is that on exams you might be under pressure and you forget all of these steps. So the only way that can help you not to forget the steps of how to get the results, where to get the numbers, which number to report, or which number to look at, or which number to calculate, is by practicing. So let's say we're work on chapter 21, and chapter 21 is simple regression model. And for simple regression model, everything we need will be in fit y by x right here under Analyze. So the examples will normally tell you which variable is the dv or response variable, and which variable will be explanatory variable. There will be a few, one or two questions that they will not tell you directly that which variable is the dv or the response. For those questions, you need to read the question carefully, because the question will tell you which variable is to be controlled. And the variable that we want to control, like let's say the question says the management wants to increase profit, management wants to increase efficiency, or customers satisfaction, right? Or customers loyalty. If that is the question, that question is telling you that this variable is response, this variable is the dv. So we put dv into y response. Let's say there is another variable and the question is asking you to create a simple regression model or linear model, and let's say that is number of employees. That's all you need to know. You need to make sure you know that response variable or dv goes to y and explanatory variable goes to x. Click OK. You will have a scatter plot. There will be one question, probably one or two questions on the final exam that might ask you to remove an outlier. So if that question was given to you, and let's say the question tells you company number 32 is an outlier, remove it and perform the analysis and see what the results are. So one way is I check on the points and I see that that outlier is number 32. I click on it and then right click and row exclude. I can also hide it, right? But is there another way? Yes. Go back to the actual data, and in the actual data I can click on the row 32, right click and just exclude it. So I'm excluding row 32. Okay. And I'm going to rerun the analysis because the first analysis was not started with this correctly. So it's profit, number of employees, and click OK. So I'm recording this session and I will upload it for your class. So that's your scatter plot. What are we looking for in a scatter plot? We're looking for linearity of the relation. If I would remove this 3 case down here, I can say I would have a linear relation, right? They're almost on a certain line. And what else do I need to see? I need to see the correlation. Red triangle. So if you want to add information on jump, you need to, if you want to add information on jump, you would need to click on the red triangle, or change anything, you need to click on the red triangle. Click on the fit line. That's your regression line, or simple regression model. And from here, I need to look at the regression model itself. So the correlation is not reported here, okay? If you want the correlation, red triangle, summary statistics. Red triangle, summary statistics will give you correlation. This number is 0.39. 0.39 is between 0.2 to 0.4, which is a weak relation. Is it significant? Yes. There is a significant positive correlation between the two variables, number of employee and profit, and that's a weak relation. Of course, there is a upper and lower 95% calculated here. Covariance is also calculated as here. Mean standard deviation of both variables, the response and explanatory, are right there. The linear regression model is right here. So on exams you will have a question asking you about the model, and you will see this model, but the slope and the intercept will be empty, and you need to key in a number. Make sure you put these two numbers. The number that is not attached to any variable is your intercept. The other number is the slope, and that's your number of employees, right? So make sure on exams and quizzes, check for roundings and make sure you round correctly so that you don't lose any credit. R square is right here on the summary of fit. How to interpret it? Multiplied by 100, and that would be 15.8% of variation in profit or in response is explained by variation in number of employees, or explanatory variable IV. Another thing I can see from here is the root mean square error. That's your SE, standard error of the model. That's your SE, or standard error of the model, is 460. It's a large number, and I can see that here. The range of, look how far some of these values are from the line. That is creating a high value of SE, or standard error. And in fact, if we would remove these outliers, of course, there would be a better fit line right there. But that's not the only thing we have here. We also have parameter estimates. So we don't report analysis of variance at this point for simple regression model, but we report the parameter estimates table, and parameter estimates table is actually the slope and the intercept that we have in the model. They're right here. On the right hand side, we can see the p-values, and they're telling us if this slope and intercept, they're calculated significantly, they are reliable or not. So you can see that the slope is reliable, it's less than 0.05, but intercept is not. Intercept is more than 0.05, so it's not reliable. Other ways of checking reliability or checking significance of your slope and intercept is looking at the t-value. T has to be 2 or more. Standard error formula in the PowerPoints that shows there's a formula that calculates the standard error for intercept separately and for number of employees separately. That's your standard error. where do I get the confidence 95% interval? I just, on the parameter estimate, I right click on the parameter estimates, right click, columns, and down here you will have lower 95, and down there you will have lower 95. I need more space. Column lower 95 and column upper 95%. Right? So if the question asks you what would be the new lower and upper 95% confidence level if we hire, for example, 10,000, or we change number of employees by 10,000. How do we answer to that question? You just need to multiply the lower and upper confidence levels by 10,000. If it's 5,000, just multiply it by 5,000. It's that easy. Okay, so that's pretty much chapter 21. What do we have on chapter 22? Chapter 22 is more into checking the conditions of regression model. What are the conditions we check for regression model? There are three most important things we need to check on residuals, right? So linearity we have already checked. The next is normality of residuals, independence of residuals, having similar variances or homoscedasticity of residuals, right? So where do I find those? This is my linear fit. This is my regression model. So on the red triangle of the regression model, not for the scatter plot, for the regression model. Click on the red triangle and take. So what I'm going to do, I can start with the plotting the residuals. If I click on plot residuals, in fact, it's going to give me any type of plot from residuals. So I click on plot residuals and I can see those plots, but not all of these are, I'm not interested in all of these for this analysis. I want residuals by xplot. And residuals by xplot, so in fact, I have my independent variable, my explanatory variable down here, and my residuals of the profit on the y-axis. And that's what I'm looking at. So the question is, do we have similar variances here? And what does that mean, similar variances? Moving from left to right, do we have the same range? You can see that it's not. By moving to the right hand side, this range of values are increasing. A good sign to know that you do not have similar variances is very simple. Are you seeing a triangle or partially a triangle here? I can see a triangle here. That triangle is telling me by moving to the right, by increasing the IV, by increasing the explanatory, the variation is changing. The range is changing, or the variance is changing, right? So as a result, we do not have that variance. How about normality? So that's my quantile plot. How it should look like? It should look like all these residuals are supposed to be on that center line. Or worst case scenario, they are supposed to be in the range between the upper and the lower bound. Are they in that range, all of them? No. You can see that they're changing, especially on that part. They get out of the confidence level out there. And that makes them, that shows that, indicates that we do not have normally distributed residuals. So residuals are not normally distributed. Okay, so another thing I can check is, I can check the, if I can find it here, I can also check Darwin Watson. So Darwin Watson, I could not find it on fit y by x, but you can see it on fit model. And it does give you exactly the same model. It's just JMP has the Darwin Watson on fit model, profit. Even if I check the book and the book says the same thing, it says use the fit model. So profit, number of employees, it's the same data. We have excluded one case. Click run, and on that response, the red triangle, go to row diagnostics and Darwin Watson test. So this is exactly the same thing that the book also says, that use this method. Okay, so click on Darwin Watson test, and if you check your results, it actually appears down here at the end. Right, Darwin Watson test. Do you still have your model? Yes. Same number, 91.007. Number of employees, the slope is 0.007. So same p-values, right? You can get all of those results right here. So for Darwin Watson, in the past I told you if d value is between 1.5 to 2.5, if d is between 1.5 to 2.5, we have independent residuals. But it's more accurate. You know that these ranges change by sample size. So as a result, let's just stick to one thing, p-value. How to use the p-value to decide? Red triangle can actually give you the p-value. That's your p-value. If the p-value is below 0.05, the residuals are dependent. They are not independent. If the p-value is less than 0.05, residuals are dependent. In this case, p-value is more than 0.05, so residuals are independent. That means there is no pattern, there's no significant pattern among residuals. There's no autocorrelation there. Okay, so on chapter 22, we actually should have that here. Don't see where it's here. Okay. So that was chapter 21 and 22. Let me go chapter 22. So look, these are the changing variation and the homoscedasticity. All of those are the same again here, but I think the Darwin Watson is the one that I wanted to show you here. So this is slide 38 on chapter 22. Your hypothesis for the independence test of residuals is this. The HO is rho. Rho means the autocorrelation. It shows the relation between the residuals themselves, right? Rho is 0. That means the hypothesis, null hypothesis for Darwin Watson test is residuals are independent. 0 means there is no relation, there's no autocorrelation among residuals. That means they are independent. So if p-value is less than 0.05 on Darwin Watson test, we reject this. If we reject this, that means residuals are not independent. This is saying residuals are independent, right? Independent means there's no relation between them. Rho is 0. Rho represents relation. So it's showing that there's no relation. And if we reject HO, how do we reject HO? If p-value is less than 0.05. If p-value is less than 0.05, we reject this. So for Darwin Watson test that we just did, p-value, if p-value is less than 0.05, that means residuals are dependent. In this case, it's more than 0.05, so they are independent. Or we could not find enough evidence to reject the fact that they are independent. So remember that for exams, for quiz, we're not going to use the lower and upper D values. We're going to use the P value, and I just showed you on JMP how to do that. You actually have it on my earlier videos as well. Just need to watch those if you want. And you don't need that formula, okay? So that was simple regression model. Let's check. 23-24 is about multiple regression. 23 and 24. Multiple regression. So I think one of the students asked when I said beta 0, beta 1. So we have those formulas and beta 1 and beta 0 here as well. Beta 0 represents intercept, beta 1 is slope of the first explanatory variable, beta 2 slope of the second explanatory variable, and until you have k explanatory variable. What is epsilon? Epsilon stands for errors or residuals, and it follows a normal product distribution with expected value of 0, variance of sigma square. I believe that's when I was saving this, is jumped right there. And again, same as simple regression model, we want to see that observed errors are independent. Independent for residuals is Darwin Watson. Equal variances or homoscedasticity, we use a graph of residuals, plot of residuals for predicted. And we want to make sure they are normally distributed. You can use quantile plot. Okay, so let's really quick go over an example on JMP. Okay, so we do not use the fit y by x for multiple regression. Use a fit model. Of course, for the partial slopes. If you want individually find those slopes, you use a fit y by x. So profit is my dv, and let's just say that, let's say the question says these four: number of employee, profit per employee, assets, percent profit per sales are the explanatory variables I have. I did not take sale because sale has a high correlation with profit, very high correlation with profit, and that influences the results, make the results quite not what they were supposed to be. I use the minimal report because I want to see certain numbers. If I don't, nothing changes. I still have the same results, but I will have more graphs, more results, and it's going to be more complex. Click run. So that's my model. That's my the primary estimates. This is the intercept plus 0.004 times number of employee plus 0.0016 times profit per employee, and so on. If you want to see this in a shape of a model, you can go to the red triangle, click on estimates, and show prediction expression. So what that does for us at the end of this report, it just creates the equation for us, but you don't see the equal. There should be an equality here, equal sign here, and on the left hand side you have response profit. So estimation of profit equals to this form. Okay, and I can see these are my estimations, standard errors, t values. Can I calculate the upper and lower 95% confidence level? Yes, that's right there. So just right click on the primary estimates, columns, and upper 95 and lower 95. Remember that for the multiple regression model, you also need a VIF. So VIF, right click, columns, just VIF. What is VIF for? VIF is for co-linearity. I have taught this in the past, so if you don't remember what collinearity is, please watch the videos in the past. Collinearity is high correlation. Collinearity is a problem for multiple regression. It makes the multiple regression model to become not reliable. So if there's a high value, especially if more than 10, if the VIF is more than 10, then it shows that 2 or more than 2 of IVs or explanatory variables have highly correlated. Okay, so in this case we can see that they are they're okay. Remember, even if you read the book also says 2 critical numbers. It says 10 or 5. So if you want to be more accurate, use 5 for collinearity. If you want to be less accurate, you can use 10. I believe that for this, for most of the homeworks, we are using 10. Okay, so if they are less than 10, they look okay. However, that 7 is a big number. And what do they indicate? They indicate that, and in this case, we don't have collinearity problem because they're all below 10, and that means the correlation among the IVs, they're not high. Okay, so what else do we report here? I can see that my R-square value is 89.7%, and that's telling me approximately 89% of variation in response profit is explained by or is built by variation in combination of these IVs. But are these IVs all significant? The answer is no. We can see that the p-value of 2 of them are not significant. Another sign here is 0 is included in the interval. Do you see that? 1 is negative, 1 is positive. The upper and lower confidence level, they are supposed to be both positive or both negative to have a significant calculation of the coefficients or for the slopes. But in this case, we can see that the 0 is included, so these two are not significantly calculated. As a result, to have a reliable model, what we can do, we can remove this. So profit per employee, I'm removing it. How do I know it's profit per employee? The highest p-value is calculated down here, so it's not less than 0.05, so I remove it. 0.28 for number of employees, still not showing significant. Now my model is significant. A big difference between checking p-values for simple regression and multiple regression is, for simple regression, intercept must be significant, must have a p-value less than 0.05. But for multiple regression, we do not check the p-value of intercept, we just check the p-value for each of these IVs. Okay, and of course the confidence level will change, so you need to calculate the lower and upper confidence levels one more time, and also the VIF will change. VIF was 7 and 6 and 1, but look, now they're both 1. What's the lowest value for VIF? 1. And VIF of 1 means that your explanatory variables are completely independent. They're not having correlation. Okay, so that was creating that model. Now checking assumptions again, right? One of the assumptions was checking outliers. Check outliers using Mahal test. I go to multivariate method, multivariate, and select profit and all those others. Click OK. That's scatter plot matrix. These are all the correlations that I can report. And now I can click on the red triangle here, and down here I have an outlier analysis, Mahalanobis distances. So Mahal test or Mahalanobis distances is not going to be a question on exam because it's not given in the book. But I just explained this to you because I want to make sure you have a way to find out if an outlier should be removed or not. So if you click on Mahal test, the Mahal test will actually give you a plot here that's the highest. If a value is higher than, if a point is higher than that line, could be considered as an outlier. So you can see this point. If I bring number 28, this one is number 16, and number 17. These are the ones that we can consider them as outlier because they're outside the 3 times. This is actually 3 times standard error. Okay, standard deviation. So, and you can remove outlier if you need to. So that's one thing to check. But for exam, do not remove outlier unless the question asks you. There are not many questions which will ask you to change things. There 2 questions. One will ask you to remove outlier on final exam, and there might be a question on your quiz or project which will ask you to use transformation. So transformation using jump, I created a video for you here. You can watch it. That tells you how to create a new variable or a new column and multiply 2 other variables, divide 2 variables, or multiply a variable by, divide by 100, multiply by any certain number, or create a pair, for example, salary pair, for example, per square feet calculations. So I show you here how to do that, okay? And that's pretty much easy. So we're doing nonsense here. So what else do I need to check here on multiple regression? I need to check my residuals, right? So I go to the row diagnostics and I click on plot residuals by predicted. Plot residuals by predicted. So for simple regression model, we did not use the by predicted, we used by X, which is by the independent variable. For multiple regression, we use by predicted. What do we use this for? Similarity of variances. From left to right, are the variances changing or they are constant? They're changing, right? You can see a triangle or multiple triangles in this process, and that shows that this is heteroscedastic. There is no similar variances here. Can I check independence of residuals? Yes. Darwin Watson test. Row diagnostics, Darwin Watson test. That's right there. Red triangle p-value. It's more than 0.05. Residuals are independent. And I can also check normality. So how to check normality? Let's see if we have it here. Normal plot residuals by normal quantile plot. It seems quite normal. It's in the range, and majority of them are on that line, so it looks normal. Okay. You want to be more accurate on normality of residuals, you can always use Shapiro-Wilk test. Shapiro-Wilk test uses a p-value. I've explained that in my previous videos, but you don't need, for exam, you don't need to use a Shapiro-Wilk because that's not said in the book. But if you have a graph that you're not sure, should I go for normal or abnormal, I would say use Shapiro-Wilk. That is perfectly accurate, and use p-value. Okay, so we did this one. What else can I check? I can check the normality, independence. I did outliers. I did similarity of variances. We checked collinearity, VIF, right? Scatter plots, linearity. We checked all of them. And there was a question on marginal versus partial slopes. So for partial slopes, of course, that JMP fit model results will give you all those partial slopes. So these are the partial slopes. Right, these are the slopes that are partial, and if you want to see their confidence level is so 95% right there, right here. Okay, but if you want marginal, so you can use the fit y by x and profit and all other variables here. So this will run each of these individually together with the profit. So number of employees fits the profit, profit per employee fits profit separately, assets fits profit separately, so they don't affect each other. And as you can see, it's creating a four different analysis. For each explanatory variable, you have one result here, and separately for each one you can create a fit line, and also for this one you can create a fit line and see those marginal slopes, and you can compare them when individually, separately they are being fit to profit versus when you have the multiple regression. That's actually explained in the book as well.